guys, I wanted to show you how to use the 3 different tools that you will need to use for your project. Maybe some of you didn't bring your calculator. If that's the case, email me because there are some calculator emulators that you can use on computer. Okay, I'm showing you doing it on a computer screen, but ideally you'll be doing this on a calculator, on an actual calculator, so you know how to use this function of a calculator. So I'm just going to use 10 data points to reduce the time that I'm spending typing in the data. So I will first show you on Microsoft Excel. Okay, so you can see that I have some data points here, and I realized that if you use exact date for the first row, what happens is that your equation doesn't work. So basically 1, 2, 3, 4, it means how many days have passed since they found their first case of coronavirus in their country. So I chose China to show you how to do this. So for Excel, make sure you type in your data and then you highlight the 2 rows that you're going to make a graph of. And so once I highlight those 2, you go to Insert, and then you choose this Chart option, and you want to choose the one that's Scatter. Okay. Obviously, you can change certain things. This can be a China number of. Okay, doesn't matter. A couple things you can also do. You can add chart element and have X's title like this. So again, this was the number of days that passed since the first case. And then this would be a number of confirmed cases. So I could also do that. So you can tell that the data has been graphed right here, right? So first thing I'm going to do is I'm going to add a chart element, which is called trend line. Depends on your version of the Microsoft. It may look different, but what you want to find is still similar, okay? So you want to find a trend line, and you can try out different lines. So you can kind of tell on the background here that it shows a dotted line. Let me try linear. But we know the linear line wouldn't work. And so when you go to the trend line option on the side, I can actually change that to exponential. So exponential model fits quite well to the 10 data I have. And so what I'm going to do is I'm going to display the equation. So you see the equation that's displayed here. And I'm going to write that equation on the computer eventually, but for now it's fine the way it is. So what that means is that X will indicate how many days it has passed. So I could project my number of cases that are confirmed by plugging in X into equation that I have. But for fun, we will also look into other model, for example, polynomial. So if you remember polynomial function, it's a function that has x to the power of 2, 3, 4, 5, 6, and so forth. And so you can see, even though it's just x to the power of 2, it fits quite well, but we can increase the power, let me get that line, and then increase the power to be 3, 4, 5, 6. And 6 is the maximum it can go in this program. But you can see how well it fits to the line. Yeah. So that's kind of impressive. The equation can model the real life like this. So you can play with it, but the one line I'm actually interested in is the exponential model. So make sure you have that one for sure. Okay, so it's okay if you have the power model, which fits better here, that one. But the exponential model is what I'm interested in. So make sure you have an equation for that somewhere. So that's how you do the Excel. Okay, so how do we do it on a calculator? Well, you turn it on, go to Stat and Edit, and then we are gonna plug in each value. So L1 will be the list one, so I'm gonna type in all the number of days. And again, I'm gonna only do to 10, but you will have to do at least 20. And then L2 will be the number of cases that are confirmed. My allergy is going crazy today. Alright, so once you have two lists filled in, what you do is that you go to second y equal to enter stat plot, and then enter, and you are going to turn on the plot one. And then you're going to type the first graph type, and then x list is L1, and y list is L2, because that's how I typed it. So once you have everything, we're going to look at the graph briefly. So you do zoom. It's zoom 9, but if you want to know what 9 means, it's a zoom stat. So then you can see the exact same scatter plot that you see in the Excel program. Yeah. The reason I wanted you to try this one is because if you actually try 20 or more data points, that's pretty recent. What happens is that for the data for China, it flattens out. And in class, we practiced this once. And if you go back to stat and calc, there are a couple regression options. And so the one that we're going to definitely see is the exponential regression, which would be the same equation as this one that you saw in Excel. But the one that calculator does, that Excel program doesn't do, is what's called a logistics model. Okay? And L1, L2 is correct, but the store regression equation, you're going to go to vars, y vars, function, y1, and then you're going to calculate. And it takes a while, but... And this model is more useful if you actually see a flattening out of the graph. Let me show you what that means while that is calculating on Excel quickly. So I told you that I have more data, but I was just using... oh, actually, I think by 27 it flattened out. So if I draw the scatter plot of the 27 data points, what you're going to see is, do you see how it doesn't just exponentially grow, but it actually flattens out, right? So this is where the logistics model is very good to predict the regression line, and that's what I'm trying to show you on the calculator. And you will see how complicated the equation actually is. Do you see how it says C over parentheses 1 plus a times e to the, e is a number, right? E to the power of negative b times x. And the a, b, c represent those numbers. Because we stored the equation, you can go to y equal, and you will see that equation written out already here. So then, all you do is a zoom 9 to see that model fits. It's not going to fit quite perfectly here because it doesn't, it's only showing you before it flattens out, but you can see it fits quite well as well, okay? So that's another regression line that you can look at to predict some of the data point. So that's how you use the calculator. So let's look at how to use Desmos, because that's the last one that I want you to know how to do it. So if you go to desmos.com/calculator, you will see this, you will probably see something like this, okay? In Desmos, there is also a table option. And so let me type the data point. 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. I'm gonna just do 8 because you already know what the scatter plot would look like. 8, 0, 1, 7, 1, 9, 7, 5, 2, 7, 4, 4, 4, 5, 1, 5. So unfortunately, Desmos actually do not come up with the regression unlike your calculator or Excel, okay? But what you can do is that you can copy copy the equation from here. So let me actually copy down the equation. 14435.074988. Let me see. I know it's a long equation. 756 over 1 plus 1, 2 3.56396 5 it's a long number 99398 e. The power is the caret, little caret, negative 0.4 9. Oh, I changed something. Oh well. Sorry. 96195 I don't remember what the number was a second ago. Hopefully it's still approximately right. 5762126 x. Alright, so then what happens that you see the line all of a sudden, right? So let me adjust the window because my x-axis doesn't have to go to negative because we're dealing with number of days and people. And the y-axis also doesn't have to be negative. I have 10 days about, but then y-axis actually increases all the way to 5,000. Okay, so do you see how there is a regression line, that's the logistics model, and then individual dots are the data points that you have entered. So if you kind of zoom out, you will see the progression of this curve. So this logistics model is very helpful if you are dealing with data points that kind of flattens out, levels out eventually. And hopefully this is what we will see with this coronavirus. And we will see that. It's just that our fight, the battle that policymakers are dealing with right now, is that they don't want to see this sharp increase for a long time. They want to shorten the period from this time of increasing to the leveling out. So that's why we are all stuck in the houses. So hopefully this video helped, and I'm gonna type up how maybe you can do this so that on here, and then I'll post that on Google Classroom so you can just look at it and hopefully it makes sense as well. Okay guys, that's it for this video. I hope it's helpful